This is the first ALMA telescope animation of circling twin young stars by National Astronomical Observatory of Japan. Researchers analyzed the accumulated data from the Atacama Large Millimeter Submillimeter Array, ALMA for short, and they depicted the motion of a young twin star system, AZ Tauri, over 3 years. This first event, ALMA animation of twin stars, sheds new light on the origins of binary stars and the planets to be formed around them. So as we can see here, they're going to be binary stars. This achievement was made possible by the high resolution and rich archival data of ALMA, says Takanori Ichikawa. He's the first author of the research paper and a former graduate student at Kagoshima University, Japan. He said this research utilizes 3 years of observational data. The result shows the feasibility of the new research method using radio astronomical animations instead of conventional images. I hope that this method will help to clarify various astronomical phenomena in the future, he says. Our sun is a single star, but the universe is full of binary stars, which are 2 stars orbiting each other. During its youth, each young star is a binary system, is surrounded by protoplanetary disk composed of molecular gas and dust, and the disk is known to be the site of planetary formation. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. And you can see plenty of dust and debris there. So, planetary formation. Many planets associated with binary stars have actually been detected, but how the disks are formed in binary star systems and how planets are formed in those systems is still a mystery, he says. In order to study the formation of planets in binary star systems, it's important to accurately determine the orbital motion of the 2 stars and the tilt of the individual protoplanetary disks, explains Sejihisa Takakuwa, professor at Kagoshima University. Researchers suggested 2 formation mechanisms for binary systems. One is a breakup of the single large gaseous disk, and the other is fragmentation of the larger molecular cloud due to violent turbulence. In the former case, astronomers suppose that the orbit of the binary stars and the individual disks should be on the same plane. On the other hand, in the latter case, the orbital plane of the binary stars and the plane of the disks are expected to be different, as we see in this image here. This is a major issue that will affect the final orbits of the planets and the binary stars. The research team dug into the ALMA data archive. They obtained the data from the young XZ Tau system taken in 2015 and 16 and 17. They carefully analyzed the data for the first time, made an animation of the orbital motion of the binary stars, which shows that XZ Tau B moved 3.4 astronomical units, 3.4 times the radius of Earth's orbit, around XZ Tau A during these 3 years. The team figured out that the 3-dimensional structure of the orbit, in addition, analyzing the Doppler effect and the distribution of the radio waves from the disk around each star in the XZ Tau system, they found that those disks are significantly misaligned with respect to each other and also not in the same plane as the binary orbit. Previous observations with ALMA found examples of young binary stars with protoplanetary disk tilted with respect to each other, but this is the first time that the orbital motion of a binary system has been clarified, showing that the inclination is different from those of circumstellar disks. These results support the idea that the XZ Tau system was formed via molecular cloud fragmentation. This is a beautiful example of utilizing the rich ALMA archive, said Takakawa. The archive paves the way for young researchers to start conducting cutting-edge research right away, and it is true for this study. I'm very honored, he said, to contribute to such interesting research as an undergraduate student. So this is by an undergrad, can you imagine? This is what Mio Kidu at Kagashima University said, the second author of the research paper. He says, I hope to use this experience in my own future research. The study misaligned circumstellar disks and orbital motion of the young binary XC tau, published in Astrophysical Journal, September 23, 2021. This is from the National Astronomical Observatory, Japan, on phys.org. Please leave your comments and thank you for your support.